Oh, you've got your AJAX request with an XML HTTP request or Axios, or you've got a fetch method. You found your URL to fetch to, and you put in your keyword. You got the response, parsed it to JSON, and you console logged it. Now, you run this, and ooh, why is it like that? You get a response back from NASA. NASA gave me a bunch of images of their library image database. Um, but you're not done. This is not done. When you make a request, you still have to check. Still have to check if we're getting any errors. If something were to happen, like the server's down, or I accidentally type in the URL incorrectly, then I'm gonna get back an error. So I have to handle this. So before you even parse the response to JSON, you need to get that response, and this is where we're needing to have a function that says if the response is not okay, then we have to do something. We have to say throw a new error because something's not wrong. So it's throw an error, and I can say some message, anything that says this is not okay. This is not okay. And after we get that message, it's going to tell us what's wrong or something's gone wrong. So at least if the user is using the program, they know something's wrong. But if nothing goes wrong, then we can go ahead and return something. So we can say return response parsed to JSON. And now we can get rid of this line. So let's run this and see if this works. Okay, so I'm still getting the objects back, but now we have this error handling. And like I said, if something's wrong with the server or if something's wrong with the link here, I try to run this, it's going to crash the program still. So I'm still not done. So even though we have error handling here, we want to gracefully handle it. We don't want to just crash the program when something goes wrong. We want to tell the user something's gone wrong in some way. So we can say at the end of this dot then statement, we can say catch whatever error we got and take that error and console log this error. So now, instead of breaking the program, we'll just gracefully send it to the user telling them something went wrong. So let me copy this line and bring back the correct URL. Okay. And yes, so we catch the error. Now we can run this. So now we're getting objects back again, and then if I were to make the URL incorrect, it's going to tell us this is not okay, but there's no red, so that's good. We gracefully handled the error. And this is a good point to be in. But we can still go one step further. We've handled any errors that can come with our program, but let's say the user wants to search for something else right now. Right now we're searching for nebulas, but let's say the user wants to search for black holes or something else, or we want it to be dynamic. That we want the user to be able to search for whatever they want. So right now we're making an inline fetch, so we want this to be dynamic. So I could say something like we got a function that says get NASA data, and it's going to take in the search term that the user puts in, search term, and it's going to take that search term and do something with it. So in this case, we're going to return a value back to the user after they search for something, and the return value is going to be whatever they get back from this fetch. So I can move this after this return, and now we have a more dynamic code. So I can call this function and say get NASA data, put in, and now instead of searching for nebula every time, we want to take out nebula and put in whatever this search term is. So now I can put in something here saying I want to search for black holes. Black holes. And I can run this. Now it's still working, but it's more dynamic. Now the user can search for whatever they want. But the problem is still that if we go to NASA's website, NASA image library. They're using the same API. They made a website for this, but we can do the same if we search for black holes. They're using the same data, but they're just displaying it in a nicer way than I'm just testing it out. But you see they have like filtered results. You can search for images and videos and audio. You can filter things out, search by the year. If we want to do these type of things, we'd have to make a larger program. And right now, I have a function that will bring back images. I could display all these on a page like they do. But you can imagine if I kept making more functions, it's going to start being more complicated because I have to take that and filter things out. And so we'd want the program to be more organized now. So it's handling errors and it's dynamic, but we want to make it organized in a way that as the program grows, it's still going to be easy to handle. So what we could do now is abstract this function to another module. So that means we're going to make a new file, call this one, call anything like NASA data fetcher JS. So NASA data fetcher JS. I'm gonna make this new file, and we want to take this whole function we made and put it here now. And now I could export this function to be used in the rest of my program that I make. So module.exports, and then put inside of the, or actually what am I doing, parentheses? You can say module exports equals this function that we just made. So we're exporting this function now to all of the files in this directory. So now when we go back to our index.js, we can still do the same thing. We'll have to import it now. So we can say const get NASA data, or we'll say NASA data fetcher equals required. Wait, I think I'm getting the syntax wrong. No, this is right, yeah. Require this file that we just made. So go to NASA data fetcher, and now I'm able to say I've imported this and I can use it in this file now, so I can still run this. Require. Oh, actually, I need to call it this now because I just imported it. So we still get the images back, but now it's in another file, so we can kind of separate our use cases into each file. But still, if I have this function and I want to add more to it, it's still not quite organized. So I could still change this more. And really, this is where we get into the difference between procedural programming and object-oriented programming. So instead of having just a function that's going to do this one thing, and now I have to make another function that's going to filter things out, or like what NASA does, filtering things out, sorting by things. Instead of having just a list of just random functions that kind of like might not be related to each other, I would want to make a class. I can make a class, call it NASA data fetcher, and this class is going to make it a little bit easier to make fetches now, because instead of typing out the URL every time, I can go and make a base URL I'm going to use for every type of function I use now. So I'll take this search up until the search URL part, put this in quotes. So now I can use this in any function I make in the future now. So now instead of having a standalone function, I can bring it into this class. So let me bring it down now. Let me make the indentation. Oh, wait, yeah, let me put it back. Okay, so yeah, let me indent this better. So, wait, I'm getting, I forgot one thing. Yeah, this base URL has to be inside of a constructor, because this is what's going to be ran once we call this class. Whenever we call this class, anything inside this constructor is going to be declared then when we use this class. So we've got the constructor here. We've got we can now take out this const part because it's a part of this class. It's just a function and part of this class, and we don't need to use this arrow function syntax. We can use a search term like this, take out the arrow function, and so now it looks much cleaner, and it's a part of this larger class. So it's a function inside this class now. So now when we want to use that function in particular, so we could have like a filter function, for example, like filter NASA data. This could take in whatever data we searched for before and do something with it here, do some filtering logic and return back. But let's say we just wanted to use the get NASA data function again. So instead of now, and I would actually need to export the class now instead of just the function. So exporting the whole class that contains all these functions now. And instead of using that when I import the file, instead of calling the function like this, I now can say now we can do some more object-oriented programming. So this is where I could say const user. Well, yeah. So we'll say user search equals a new NASA data fetcher object, and this object can now be used to use these functions that we have inside the class. So we can say user search dot get NASA data. So so this new data fetcher line is instantiating an object from this class, and this object has access to all the different functions inside the class. So this just means that we can use dot notation like this to use that function, and then say pass in whatever we want to search, because that's what we're doing in the function, pass in a search term. So we can say I want to search for Saturn pictures, and then because this is a fetch request still, so we have to say dot then now. I want to take that NASA data that we get back and console log. And one thing we're forgetting though is that we don't want to console log inside of this class function now. We can just return things now, because we are making it so as the program grows, we don't have to console log things now. We can just return back this NASA data inside of the class, and then the more we grow the project, we can decide what to do with the data then. So now we're just returning it back instead of console logging, and then once we call that function, we can console log. So run this again, and we're still getting the same data back. But like I said, if I wanted to use the filter data function, and just for now we'll just return back whatever the user types in, we can say filter NASA data. So user search filter NASA data, and we'll get back whatever we search in. So it should get back. This is not a function. Filter NASA data. Maybe I spelled it wrong. Filter NASA data. And we'll run this again. Dot then is not a function. Okay, we don't need the dot then now because there's no fetch going on, but this should still work, and we will console log this response, or this return value. Okay, so now we're getting back Saturn because that's what we searched. So that's really all there is to APIs. We need to handle errors gracefully. We need to make it so the program is dynamic, so the user can search for many things, not just one thing. We want to make it more organized, and we want it to be scalable as the program grows. That's really all there is to using APIs the correct way.